so we can start with this afternoon section. We will have we will record the full presentation of the afternoon. So we will put the presentation later on the portal, and or even external people or people who couldn't attend the meeting can see the explanation on how to use the different tools. And we changed, as I told you this morning, a little bit the agenda. So we will start with this presentation on the vocabularies by Gwyn. So, okay, thank you.
So, yes, Dick asked me if I could maybe talk a little bit more about P01 parameters in order to give you some tips and also advertise some of the tools we've got that helps with the mapping of your parameter codes against the P01 codes. So, well, most of you will know me by now, but I'm Gwen Moncoiffé. I'm from the British Oceanographic Data Center, and we're based in Liverpool. So at the moment, we've got two main tools available at BODC. One is a vocab search tool, which I'll give you the link here. And this is an open tool, everybody can use it. But for P01, it does require a little bit of understanding of the structure of the codes. So it's one you can use, but the other one is a vocab builder tool, which enables to drill down the semantic model that is behind the name of the parameter codes. And you've got the link there. And on the other hand, for this code, you actually need to log as a BODC user. And it also allows you not only to search, but to submit new codes if the code you're looking for is not there. At the moment, it was developed as a, I think I'll tell that, but at the moment it's restricted to chemical substance parameters only. And also to use, as I often recommend to people to also use the Maris hierarchical listing, the thesaurus, that goes from P08 to P03 to P02 to P01, because it provides you with that drill down hierarchy that allows to refine the search. So that's why I'm giving the link there as well. P02 is going to be reviewed. It's going to go through a major review in the coming year. So at the moment, don't be too alarmed that if it looks a bit difficult we need to do a lot of work on it in the coming year. So just to talk about the P01 parameter names, I mean, I'm assuming that most of you will be familiar with those names, and they can sometimes be very long. But there is a logical structure to them, and it's based on semantic models. To simplify the understanding, I think you need to focus on the fact that there's three main elements in the name. The first one is a property observed, which would be, for example, concentration. The second element of importance is the entity that is observed. And that entity can be either a chemical substance, like phosphate, for example. It can be a physical phenomenon, like waves, or it can be also a biological entity, like if you're measuring the abundance of a particular organism. And in that case, I'm giving the example of a taxonomically identified organism like Skeletoneba costatum. And the third element that is of importance in those parameter names is a matrix. And the matrix can be, for example, the water body and its various phases. It can be sediments and its various components. And it can be atmosphere and its various components as well. And there are other in the list. So when looking for terms, keep in mind that property plus entity is the what theme of your measurement. And the matrix is where the measurement was made. So when mapping to P01 codes, this is just to summarize the what and the where. So as I was saying, you've got the vocab search tools. So if using the vocab search tool, the what, concentration, in the search field, you enter your concentration, your keyword, well, your wild key phosphate water body, and that will return you a series of codes. Oops, from our. So in the case of that particular search, it returns 35 parameter codes for concentration of phosphate in water body. So why so many? It's because there are other elements in the semantic models. For example, I think I've got a slide. Yes, for example, the statistical terms, we do take into account the fact that a standard deviation will have its own parameter code, so that add to the listing. In addition, the matrix itself is also a semantic model. So you can have various types of matrix depending on maybe the filter that was used. It's very important to know if it was dissolved phase, dissolved particulate, and what filter was used, because it's different pore size. So that will also add to the number of codes that are returned. And then also this is specific, I think, to BODC, is that we tend to have the methods in the parameter codes. So this is the way our data model was designed in the past. So that also means that there's a lot of codes, additional codes, depending on the kind of method that was used for the measurement. More and more, we're creating generic parameter codes, and I think that the EMODnet community tend to use the generic parameter codes. But if the method is here, it is possible to use it. And finally, there is another element that adds to the diversity, which is the relationship between the measurement and the matrix. For example, if you've got, if a concentration has been reported as per unit of mass or per unit volume, this is coded in the parameter code. So this is why during EMODnet Chemistry 2, the vocab builder was released as a pilot system, and it enabled the user community to not only to search codes based on the semantic model on those different elements, but also to submit new codes to us for approval. So Rob, who is here, I think, contributed to that part of the work. So within CData Cloud, we are actually working to fully operationalize this vocab builder so that it can be used for not only for chemical substances, but also for the totality of the P01 codes. Well, the link, you've got it somewhere else. I forgot to complete the link, but you've got it on the first slides I showed. So as I said, you need to log in as a BODC user. It helps search existing terms and request new terms. I think I've said everything else. So this is the equivalent of, you might have heard about the one-arm bandit. There's a fruit machine. So basically, you just go through your different wheels, and bingo, you've got a code, or you need to request one. So this is the way it looks at the moment. So you've got measurement property, measurement statistical qualifier, chemical substance, measurement matrix relationship, and the matrix. So if we just focus on those three fields, those three wheels that I mentioned earlier, as for me they are key in trying to narrow down the number of parameter codes you're looking through. And I'll take you through it. So if so measurement property is selected, you can select, there's a drop-down list, and you can select the measurement of interest. And the measurement then appear in that preferred label box. Then going down to the chemical substance. Again, you see here it's going to appear as a drop-down box. You can enter a search term here, and it will narrow down the number of hits. So here in this case, I selected nitrate plus nitrite. Then going to the matrix, again, I selected from the drop-down list water body, dissolved plus reactive particulate. And I had filtered through GFF, so I selected the GFF filter, GFF phase. And again, then you get the compilation of the term at the top. So just based on those three elements, already there's only 6 exact match for those codes. So so 6 exact match, and it is possible to display them by selecting that option here. And this is what we see here. So again, just to help you understand the way it's built. So apart from the 3 key elements, you've got, as I mentioned before, the measurement matrix relationship, which will create some diversity in the returns. And then the statistical terms. And then the methodology, which again creates additional records. So it might be that the code you were looking for was not there. So it is possible to create it. Also, if the chemical substance of interest was not there, then it is possible to create a new one. So I took a dummy case there, my chemical substance. So you just submit that. And now we've got concentration, so not specified because I don't want a standard deviation or any statistical specification of my chemical substance per unit volume of the water body, etc. And then you've got the option to create it straight from that form. So I think that's it.